Hi to all my followers. Here we are analyzing the chemistry problem of GATE 2013. Just look at the given problem. Decarboxylation reaction of the manganese complex, okay, which is given as cis manganese complex with 6 ligands. Here 4 CO ligands, that means they are normal CO ligands. One is C13 CO ligand. So this difference we need to find. Okay, and one acyl ligand, right, which is giving 3 products. One is X as CH3MnCO5, where just observe this X product in which we doesn't have this special case, that is C13CO. Okay, right, whereas we need to check the Y product, so A, which is given as cis product of manganese complex, in which we have C13 and CH3, but in the acyl group of the reactant CO is missing. Okay, so that is the difference we need to check. And Z, the product Z, so we have given with trans product of manganese complex, in which so we just have the difference between product and the reactant is simply CO is missing from the acyl group, okay, and the C13 CO is as usual in the product. Okay, right. The molar ratios of the products X, Y, Z in this reaction is, we have given with 1:1, 1:2:1, 1:1:2, and 2:1:1. Okay, right. First we need to draw the structure of given reactant, that is manganese complex, cis manganese complex. So manganese, the transition metal manganese, coordinated with 6 ligands, hence it is octahedral. So that octahedral structure is given like this. Okay, right. Now here he said cis manganese octahedral complex with the given ligands. So how can we write a cis manganese complex? So here we simply write COCH3 acyl group as axial, and another, the normal carbonyl group, is opposite to that COCH3. So that means they both of them as axial to each other. That means they are trans to each other. In that condition only we can get the special case C13O and this COCH3 cis to each other. Okay, right. Now just look at the given reactant once again. If you see that, so we have given with octahedral complex. Just remember, it is useful in the further understanding of this explanation. We can write that COCH3 is cis to that CO group, okay, and COCH3 is also cis to this one, and COCH3 is cis to this CO, and COCH3 is cis to that COC13. So we can write all of them as like this. Okay, so this is the actual octahedral complex, right? Right. Now just remember that. Now check what is going to happen in this reactant and how it gives these 3 products. So here is the involvement of migratory elimination, so which is simply opposite to migratory insertion. Okay, so just remember these important points. In to happen, that is to get migratory insertion, the 2 groups which are involving in migratory insertion must be cis to each other. Okay, they must be cis to each other. That means they should be cis-idal in positions. Okay, and migratory insertion involves the intermediate vacant site. Okay, right. And migratory insertion takes place on more electron deficient complexes. Okay, just remember these points. I know formal change or the no change in formal oxidation states of the central transition metal complexes in migratory insertions, but we can observe the exception is simply alkylidins. Okay, the charges or acceleration states changes. Okay, right. Now once again check the given reactant. Now we need to check the first product X from the reactant. Okay, so the product has CH3 and one of the CO, that is the special case C13CO, is missing. Okay, what should be reaction mechanism here? Simply migratory elimination. So in that migratory elimination, the first step is the cleavage of one of the carbonyl group here. Then there is a formation of vacant site. Which carbonyl group should be cleaved? Because here C13CO should cleave from the given octahedral manganese complex. Then only we can get the product without CO13. Okay, so that's why here in the first step the vacant site should be formed by the cleavage of that CO13. Okay, after formation of this CO13, what happens? Simply the CH3 minus can takes, or CH3 can split from that COCH3 and it takes the place of vacant site of that CO13. Okay, right. By doing that, just check here, CH3 comes here and takes the vacant site of CO13. So CH3 and CO. Okay, normal CO is just left. So this is the X product. Is there any chance to eliminate this CO? No. Okay, so only the methyl group can takes the position. The negative charge containing group can only takes the position of that vacant site which is given by, or which is left out by CO13. Okay, so that's why we can get one product of this, right? Now we need to check the Y product, in which manganese, the manganese complex is given as cis complex. Okay, right. Cis complex means here we need to think that the CO13 and the CH3 must be cis to each other. Okay, so that is the thing we need to know here. Then only we can give the answer. Okay, right. To do that, what should be what are the possibilities here in that migratory elimination? For example, if this CO is eliminated in the first step and it forms the vacant site, then the CH3 cleaves here and takes its position here in the vacant site. So just observe, we can get this product. In that we have C13O and CH3. After migratory insertion, they are cis to each other, right? They are adjacent. Okay, so they are cis to each other. Already, as we explained in octahedral complexes, any two are cis to each other. Okay, 6 ligands just they looks like cis to each other in any ways. Okay, right. Now, is there any other possibility to get the same cis product? Yes, if this CO eliminates and it forms vacant site here, then again CH3 can insert here in the vacant site. Okay, if you do that, we can get this product. Okay, so in that condition, this CO13 and the methyl group here both are cis to each other, right? Okay, so these two cis to each other, these two and these two also. Okay, right. So that's why we have two cis products, two cis Y products. So that's why here the percentage is 2. Okay, so the 50% for as a Y product. Now we need to check the third one, that is Z complex here, trans manganese complex. Trans means here CH3 and CO13 must be trans to each other in the given in that product of manganese octahedral complex. Okay, right. To get that, what we need to do? Here we have CO13. So for this CO13, the inserted CH3 must be trans to each other. Then in that condition, this CO group, okay, must be eliminated and it should form vacant site. So after formation of vacant site, this CH3 comes here, takes the place of vacant site of that CO. In that conditions, these two are trans to each other. Okay, right. So this is the product Z. Is there any other possibility to get CO13 and CO39 methyl group or trans to each other? No, this is the only way. Okay, so here we have X as 1, Y as 2 and Z as 1. So simply option B is the correct answer for the given problem. Okay, right. So just visit and join on chemasters.online and just prepare CSR net gate JOM as set examinations by taking the courses with very minimal charges or minimal fees to get success by just playing on mobile or laptop. Thank you.